Hello students. Today we are still in Chapter 8. We learned about the marginal product of labor last time. So now let's talk about the marginal product of capital. So recall we use K for capital because the letter C is reserved for consumption. That means we're going to abbreviate the marginal product of capital not as MPC, but rather as MPK. It is approximately the change in output when you add one more machine. If you want to see a more exact definition, that'll be in intermediate micro. So, some myths to watch out for. Just as the marginal product of labor is not average output per worker, so also the marginal product of capital is not average output per machine. Do not confuse them. It's also not the same as number of machines per worker. Watch out for that myth as well. So it's very similar to the MPL. So here's an example where you can see how it is calculated. If you have no machines, you have no output. Let's say when they have their first machine added to their factory, it produces 50 units. Now, because output rose from 0 to 50, that's an increase of 50, so the MPK is going to be 50 in that case. When you have a second machine, output's going to rise all the way up to 90. If you had 50 before and now you have 90, that's an increase of 40. That means MPK is going to be 40 for that second machine. When you have three machines, total output is going to be 120. That is an increase of 30. 90 and 30 is 120. So if output goes up by 30 when you add one more machine, that means the MPK is 30 for that last machine. If you have four machines, you get 130 units of output. That is 10 more than you had previously. Thus, MPK is 10. So, most books will have a table of the MPK that looks similar to that. Your book shows a table that's a bit different. So here's what your book is doing. They put the MPK in between the rows, but the math is all the same. So if you have two machines, you have 90 units of output. With one machine, it's just 50, so output goes up by 40, so MPK is 40. All we're doing is putting that 40 in a different row than we were previously. So the 40 goes in between the rows over here instead of going at the end of the row like it did back there. So it looks different, but it's actually the same thing. Same for the first value of the MPK. So if output goes from 0 to 50, when you add your first machine, the MPK is going to be 50, so you write that over here in the textbook's approach. So here's an exercise for you guys. As I emphasized earlier, the MPL is not average output per worker and the MPK is not average output per machine. When you fill in the rest of this table, you'll have to find that out for yourself. So go ahead and pause the video while you fill in all the blanks. Alright, let's go over the answers. So we have 0 machines and 0 output at first. The MPK was 30 for the first machine. That means that the first machine is going to add 30 units of output. 0 plus 30 is 30. So that's how I got this value. The MPK was 25 for the second machine. That means that the second machine is going to add 25 units of output on top of what you already have. We already have 30, so if we add 25 on top of that 30, we get 55. 30 and 25, 55. We're already given the total output when we have 3 machines or 4 machines. However, we had to calculate the MPK. So we look at how did total output change each time we added a machine. When we had 2 machines, we had 55. With 3 machines, we had 70. That's an increase of 15. 55 and 15 is 70. So we write down 15 over there. For the 4th machine, that caused output to go up to 80 before it was at 70. That's an increase of 10, so that last MPK is going to be 10. To fill in the last column, we just find output per machine. Just divide the total output column by the machines column. So you can't divide 0 by 0, so that'll be a blank. 30 over 1 is 30. 55 over 2 is going to be 27.5. So that goes over here. I have 70 over 3. I think that'd be 23 and a third. Yeah, 23 and a third, if you want to do it that way. 80 over 4 is, of course, 20. So, as promised, the MPK is in general not equal to output per machine. They coincide for this first value over here, but other than that, they're always different. Here the MPK is 10, but average output per machine is 20. And here MPK is 25, there it's 27.5 for output per machine, and 15 does not equal 70 over 3. So don't conflate the MPK with average output per machine. We can graph the MPK just like we graphed the MPL earlier. So we said if you have one machine, you have 30 units of output, so you have 130 over there. 2 machines gave us 55, 3 machines 70, and 4 80. The MPK is going to look like this. So the MPK for the first machine was 1, so we put that over there. Second machine, it was 25 because it boosted output by 25, so 2 and 25, 3 and 15, and 4 and 10. So that wraps up the marginal product of capital. So now we go on to a very important topic: diminishing marginal returns. So like I said in the introduction, you'll hear about this not just in this econ class, but in all the other econ classes you ever take. So the law of diminishing marginal returns says that marginal products are decreasing. So in other words, if you keep adding more and more and more workers, output goes up by a smaller and smaller amount each time. Likewise, if you keep adding more and more machines, output is going to go up, but by a smaller amount each time you do it. So the MPK should go down as you add more machines. The MPL should also go down as you add more machines. So here's a graph where you can see this happening. Here we have total output on the y-axis, and we have workers. So our first worker gives us, looks like roughly 2.5 units of output. If you add a second worker, output goes up, but it doesn't double. Output is now only about 3. So output rose by about a half when you add the second worker. If you have a third worker, output goes up again, but by an even smaller amount. Looks like roughly a third if I'm just trying to eyeball it. So first output went up by 2.5, then went up by a half, and then up by a third. If you add a fourth worker, it goes up by an even smaller amount. So this graph here is consistent with diminishing marginal returns. So to be clear, we're not saying that total output is falling. Rather, we're saying that the marginal products are falling. That's different. So total output can keep going up, just goes up at a slower and slower rate, like it did back here. So total output keeps rising, but it rises by a smaller and smaller amount every time I add another worker. So the graphs we had earlier, here are the marginal product capital from that example, and we have the marginal product labor from the earlier example in the previous episode. You'd see that the marginal products are consistently going down. So total output still rises, but just goes up by smaller amounts. So what does this imply for our production function? It means our total output curve will have to be concave. So recall back from chapter 2, we talked about what does it mean to be concave, what does it mean to be convex. The way to figure it out is pretty straightforward. You just pick any 2 points on your curve. Then you connect those points with a straight line. Now if your line is always below the curve, no matter what 2 points you pick, then your curve is concave. So with this picture here, the line's always below the curve for this pair of points. If I had picked a different pair of points, like maybe this one and that one, the line would still always be below the curve, and this point and that point, again, always below the curve, no matter what points I pick. So this one is concave. Likewise over here, if I join these 2 points, line is always below the curve. If I picked a different pair of points like this and this, the line is still always below the curve, so that one's also concave. The opposite is a curve that is convex. For a convex curve, that means the line is always above the curve. So over here you see lines above the curve, so that's convex. Here also lines above the curve, so that's also convex. So we saw a shape like this one is consistent with diminishing marginal returns. So this shape here you can see is concave, like this one down there. So it's concave, and you can see when I add one worker, I get a big increase in output. If I add a second worker, it's a smaller increase. Third worker, smaller still, and so on. So that fits our law of diminishing marginal returns. Now, why exactly is it that I can be so confident that marginal returns are always decreasing? Well, here's an example that can show you why that would be true. I'll talk about an example with workers and computers, but the same kind of logic would work for many kinds of other firms as well. Let's say we start out with 5 workers and no computers. So in our notation, recall we had L for labor, so if we have 5 workers, that means L is 5. K is number of machines, so 0 computers means K equals 0. Now let's say we're going to add 5 computers to this firm. That's going to make things way more productive. Our workers used to have to rely upon pencil and paper, but now they have computers, so that should make things a lot more efficient. The MPK, the marginal product capital, should be very high because we're getting way more efficient when we add these first 5 machines. So seeing adding the first computer did so much good, perhaps the company thinks, let's try it again and now give each worker a second computer. So now we have 10 computers and we have 5 workers. Now, output will probably go up again, but not by a whole lot. If you already have one computer, then adding a second computer doesn't do a whole lot of good. I mean, perhaps you can do something on the machine number 2 if the first computer is busy working on something. So maybe there's some small productivity gain there, but it's not going to be a whole lot. If you have one computer already, getting a second computer is not all that awesome. So MPK is going to be a lot lower for the next set of 5 computers. If you try adding 5 more computers, so now we have 3 computers per worker, that's probably going to do almost nothing at all to output. If you already have 2 computers, you can do all the computer stuff you want. The third computer, I'm having a hard time imagining how that would be helpful. So output's still going up, but it's going up a lot less if you already have a lot of computers. So the marginal product of capital, the extra output you get when you have more computers, keeps going down. You keep getting more output, but it's not going up by a whole lot. The same is true for workers. So let's go back to when we had 5 workers with 5 computers. So each worker had a computer. If you hire 5 more workers, you should get more output, but it's not going to double. You double the number of workers, but you're not going to double your output. That's because there aren't enough computers for all these workers to use. If you have twice as many workers as computers, then some people are going to be losing time waiting while they wait for a computer to become available. So each worker is a bit less efficient now. So it'll probably be more output because having more workers is probably a good thing for producing stuff, but output's not going to go up by a tremendous amount. Output rises but at a slower rate. If you keep doing this and add 5 more workers, you'll see the same thing happen again. So having more workers is probably a good thing for the firm to make more stuff. However, those last 5 workers are not going to be terribly efficient. That's because they just don't have enough computers to go around. If you have 3 workers for each computer, then a lot of times you're going back to pencil and paper, which is not terribly productive. So perhaps now output's only going up by a tiny amount. So you first start adding workers, you get a lot of extra output. If you already have a lot of workers and you keep adding more and more, output goes up only very gradually. So the same kind of story works for a lot of different firms, not just with computers and workers. So that's why it's called the law of diminishing marginal returns. It applies so broadly, it's almost like a law. So again, diminishing marginal returns is super important. You'll see that throughout your econ education. You might have noticed a parallel, I talked about this a little bit in the introduction, between it and the law of diminishing marginal utility. When you double your consumption, you're better off, but you're not going to be twice as happy. If you're thinking about lunch right now, if you had 1 hamburger already, then having a second hamburger is not going to make you twice as happy. You're already kind of full, so there's diminishing extra happiness from having more burgers. So it's true not just for burgers and consumers, it's also true for factories and workers and machines. So that wraps up our section on diminishing marginal returns. Hugely important topic. In our next episode, we'll move on to start talking about costs.